Hello, thanks for joining me today. My name is Mark Bramstedt. I'm a soil scientist I've worked with soils for over 40 years. Can you imagine that? Somebody gets paid to play in the dirt. So come, let's go explore about soils here. We're going to go into the woods behind my house and see the soils in different landscapes. Hey, how you doing, class? You know what I'm holding in my hand is kind of like a buried treasure. This is stuff that you might not think about very often, but to me it's very important, and it's very important to you as well. We're going to talk about this and see what this stuff really is. Now, a lot of you might call this stuff dirt, but to me, dirt is a dirty word. I call it soil because soil gives us so many things, provides us life, provides us like these trees and the prairies that we have around, and so we're gonna take a look at this and see what soil really is. One of the things about soil, it's not just dead stuff, it's not just ground up rocks and minerals, but it's actually alive. And you can see all these plant roots in here coming out of the soil. The soil is reaching deep into the ground to get water and nutrients or food to help the plants grow. There's also a little earthworms in here and other little critters, and critters that we cannot even see that change the dead leaves to food for the plants so they can continue to grow. Soil has a lot of features. One of the things I noticed about this sample that I have, it is very, very dark. It's almost black, or it is black, and that's because it is considered a rich soil, and that means rich in nutrients for the plants to grow. As well, if you're a farmer, it might make you rich because it is very fertile soil and grows very well. Now, one of the things that I noticed too, besides the color, are the little shapes that are in there, and we'll talk about those too. And soil also has a way it feels, and we can discuss that as well. But let's talk about how dark it is. That's from the organic matter, the dead leaves that have died and the worms have chewed up and made food for the plants and have darkened the soil. It's a color in the soil that is very common in or near wetlands or in a prairie. So this is an area near a wetland. There's a wetland behind me. We can also see the different shapes in the soil. That's called the soil structure. And this almost looks like coffee grounds. It's very fine, granular structure. That's very good structure, and that allows the plant roots to get down through the soil and to get the water and the nutrients as it needs. We can also feel the soil and try to rub it and squeeze it between our fingers to determine how much clay is in it. Now, this doesn't hold together very well. I don't feel any sand, so this sample has a lot of silt. Sand, silt, and clay are three things, three particles that make up soil. Sand would be about, if we blew a sand grain up to the size of a beach ball, then silt grain would be the size of a point of a ballpoint pen maybe, or the head of maybe a ping pong ball, let's say that. So a beach ball is sand, silt is a ping pong ball, clay would be like the point of a needle, so it is very, very tiny. So we can feel the clay in the soil because it's sticky and will hold together. We can feel the sand in the soil because it's gritty and scratchy, but if it's real smooth like this one is and powdery, this is really high in silt. And silt is one of the things that we're blessed with in Illinois. We have a lot of silty soils on the surface of our ground, and that holds water for plants to use. That's the best of those three for holding water for plants to use. But look how the plant roots just cling to the soil, and that's where they're grabbing all their nutrients out of the organic matter or the decomposed plant material that's in the soil. I got that sample from right here just by using a spade, a shovel to dig it up. Also, I used a soil probe. I have two soil probes there to go a little bit deeper in the soil. And I can show you it's not all black all the way down. So I have a sample here where you can see the upper part of the soil is that dark, rich color that we had. But as we get deeper into the soil, we see these yellows and browns and tans that are in the soil. And we also start seeing some rocks that are down here. Well, the rocks are from the glaciers that came through Illinois, and the soils in Illinois are all about the glaciers. And those were big sheets of ice that came across the state, taller than the Sears Tower in Chicago, the Willis Tower in Chicago. Very, very high, heavy sheets of ice that carved out the Great Lakes. Well, they came all the way across most of Illinois and brought with it and sand and gravel and rocks and crumbled those up and helped us make soil here in Illinois. So these soils are about 14,000 years old that they've been developing. And so here we have a soil that's near a wetland, that's why it's so dark, and it's silty material that's overlying material left by the glaciers. So it has two parents. It has silty material on top and glacier material below. And that's like soils everywhere. Soils look like what their parents were like. We have about 600 different kinds of soil in Illinois, so this is just one of those types of soil that we have here. And it depends upon where it is in the landscape. If it's on a flat, low area, it's going to look different than it's at the top of the hill, and we're going to look at that here in a little bit too. So right now we're near the bottom of the hill, and you can see that the surface is very thick, overlying silty material with the browner material below that was left by the glacier. So we moved down the hill, and if you can see around me, we're down in a low spot, and this is actually a wetland. And I've taken a soil sample, and look how thick this surface layer is, how dark it is, dark and rich. That's high amounts of organic matter that are in here, helping the plants to grow. And the organic matter doesn't decompose very quickly in a wetland. Decompose means breaks down by the little critters that are in the soil to break it down. It stays here because this area stays wet so long. There's not enough oxygen or air in the soil to break it down as rapidly as it did where we were before. So we have a much thicker, dark surface layer. Now, soils form in layers. It's not just the same from the top down. So this is the top of the ground here, and I'm going down about 4 feet into the soil. And it forms in different layers. And it has different colors, and the colors mean things. We already know the color of the darkness means that it's rich in organic matter, but if you look down here near the bottom, you can see it starts to get shinier about here. That's because there is water. It's saturated with water from about here downward. And you would expect that in the wetland, the water to be high up into the soil. In fact, in most years, I would be standing in water, but this is a drier spring. As we get down into the soil, you can see that it actually becomes lighter in color down here and changes to like a light gray with some orange spots. And the orange spots are actually concentrations of iron that are in the soil. The gray places are where the iron has been removed from the soil by all the critters that are in the soil. When soil is really, really wet for a long time, there are certain critters that use the iron to help in their life processes, and they convert the iron from a form that is the reddish form to a form that can move with the water, and it strips the soil of the iron, and that's what the gray means. The gray is uncoated soil particles where the iron's been removed, and then concentrated back where you have these orange spots in the soil, and that's concentrations of iron. That's a chemical process called oxidation and reduction, and it's something that you can learn about as you're getting older and learning chemistry, but it's a chemical process that happens in the soil because of the little critters that are down there. So this is a very good example of what a soil in a wetland in northern Illinois would look like. And we have a lot of soils A lot of our land area in northern Illinois was wetlands before it was settled by Europeans and turned into farmland. And this beautiful black surface is really, really good for growing, but the farmers needed to do something to remove the water to make it productive for their crops. So they had to put in artificial drainage like drain tile or ditches to help drain out the water faster so they could farm it in the springtime. We've actually walked up the hill in this woodland, and so we're higher above the wetland by quite a bit of distance. And I've taken a sample, just a few, about 1.5 foot of soil sample here that's different than what it was in the wetland. It has a thin, dark surface. There's not as much organic matter here as there was down in there, so it's not as rich of a soil, but it is silty in the top part, and it's very brown in the area below that. And that's because it is not in an area that's really, really wet, so the iron is like rusted. And we call that oxidized iron. So the air is around it, the oxygen is around the iron, and it makes it rusty colored. So a brown soil is usually a brown subsoil. So we have a topsoil here and a subsoil here. Topsoil is a little bit dark, but not as dark as our wetland soil was. And the subsoil is very brown. When we see very brown subsoils, we know they're higher on the landscape than when we see those gray subsoils like we saw in the wetland. The gray colors indicate that the soil is wet for a long time, but here we see that the soil does not get saturated with water for long periods. So if I was going to build a house, where would I want to build it? Would I build it in the wetland where I have a lot of water, or will I build it on a hillside or a hilltop where I don't have to deal with water in my basement and a lot of sump pumps to keep the basement dry? I would build it up here. Okay, this is a preserved sample that I made years ago. It's very similar to the soil that we looked at in the wetland. So again, you can see the layers that are in here, the dark surface layer, and then it gets grayer and grayer as you go downward, indicating again that this is a wetland soil, or soil that's saturated with water for a long period of time. Mostly in the spring, but sometimes in really wet areas it can be saturated year-round. And again, the gray colors mean the iron has been removed from the soil from the processes caused by the little critters that are in the soil using up that iron and making it go into the water and move away. Here's another sample of soil from northern Illinois. Remember again, there are over 600 different kinds of soil in Illinois alone. And this one was a soil that I took from a hill on a prairie west of DeKalb. And you can see the surface layer is not as dark as the wetland soil was, but there is a darker surface layer. It becomes very brown in here, again meaning the iron has a lot of air and oxygen on it, not saturated with water. And then down at this layer, there's an abrupt change that it becomes really orangey red at this part. This is actually an ancient buried soil that was in Illinois before the glaciers came, and this material then was deposited on top of that ancient soil. So that ancient soil is called a paleosol. So that means ancient soil. When I talk about colors in the soil and I say brown, what does it brown actually look like? Well, we have a book that we use when we describe the soils, so that it's like going to the paint store and picking out the color of paint that you want for your bedroom. So it's divided up. So these are all soil colors. And you may have seen some red colors in soils if you've traveled to the south like Georgia, or even to the west like Oklahoma, where the red colors are from the iron that's in the soil. There are two things that color soil. One is organic matter that makes it dark, and then iron makes it the red, orange, or yellow colors in the soil. The soils in Illinois are mostly on this page here. Now, if I was describing a soil that was just brown, it could have been any one of these paint chips here, but if I say the soil is 10YR 5-3, that is this color right here, and every soil scientist in the world will know what color that is. And each page, 10 yellow red, then it goes from light to dark, that's the value of the soil, and from gray to increasing strength of that color. So 10YR 5-3 is that chip right there. As we get into the wetlands and wetter soils, the soils become more gray and yellow, and actually get very pretty with yellows and greens, and even to some soils that are where the iron has been almost totally removed, and there's blues and brighter greens in these soils. These are very, very wet soils that have these certain colors, but soil is actually beautiful sometimes. And I've actually seen people make crayons out of soil, and you can color and use all these colors in drawing. So thank you for joining me today in this exploration about soil. Remember, soil's not just dirt. Soil is very important to us because it provides a place for the plants to grow, provides a place for our crops and our food. Everything that we eat has a connection to the soil. It provides the shade from the trees that grow in the soil, and even where our houses are built, the soil really matters. So thanks for joining me today, and I hope you learned something. Have a great day.